Founded 6 decades ago, Custom Building Products is the industry leader in flooring preparation and tile and stone installation systems. We're the preferred partner of leading contractors, architects, and developers throughout North America. At Custom, your success is our success. Our goal is simple: exceeding the expectations of construction professionals every day. Our commitment to practical solutions and technical expertise helps you deliver installations that are as durable as they are beautiful. Custom's rich tradition of innovation has led to breakthroughs like the first polymer-modified grout, pioneering lightweight mortars and underlayments, the original liquid waterproofing membrane, and a revolutionary single-component grout. Trusted Custom brands offer complete installation systems that ensure high performance from a single source.
Good morning, everyone. Welcome to the Custom Building Products webinar series. Thanks for joining us today. We have an exciting program and an excellent speaker. John Alley is our architectural sales consultant up in BC, and John has been a dedicated professional for 20 years. And for the past 10 has been here with Custom Building Products. We are very happy to have him as a team member. John is an active member of the industry community, sitting on the board of directors for TTMAC, or Terrazzo Tile and Marble Association of Canada. And he is currently the director of the Vancouver chapter of the Construction Specifications of Canada. I will put John's contact information in the chat so you can make contact with him later. And for those seeking out certificates, we would expect to see those mailed out or emailed within 2 to 3 days. And if you did not register for a certificate, you can add that in the chat line and we'll make sure and get that for you. So, housekeeping reminder: keep your mics muted during the presentation. Chat line is up. I'll be monitoring that so you can punch in some questions and we'll answer those, and we can circle back at the end and open up our mics and ask any questions that you may have. So without further ado, let's give the floor to Mr. John Alley.
Fantastic. Thank you, Will, and thank you everyone for attending. As Will said, the presentation today is sound attenuation membranes for ceramic, tile, and stone. This is an accredited program, so much like as Will said, if you need your credits and you have not submitted your AIA numbers or IDC numbers, please do so after the presentation and we will get those certifications off to you to be submitted. What we're going to be discussing today is understanding in a little bit more with the different classifications and sound transference that we're going to be looking at. So IIC and STC ratings for floor assemblies. We're going to be understanding how sound membranes work beneath the substrate and how different membranes can work. Comparing different styles of membranes, what's going to be better for what and what may work more appropriately for certain installations compared to others. Looking at some tips and tricks when specifying and on the construction site of how these membranes can work and how we can better get a better performance of the assemblies themselves, and then some real world examples of when different membranes can be used or different installations and how that can sometimes relate back to building code and what generally those building code standards are depending on the region and the area and whether we're dealing with a strata corporation or not. So moving right along, here's a great example of what everyone expects to experience within their house. They're looking for that peaceful space where you're not going to get the ambient air, you're not going to get confusion or not confusion, but you're not going to get disturbances from different areas, whether that's your neighbors above, below, whatever. We're looking for that quiet space. Unfortunately, what we see in reality tends to be fairly similar to this here. I know personally, myself living in a condo, I can experience this a fair bit. So there's a lot of different considerations that go into how we're going to make these floors work and how we're going to make these assemblies work to to best achieve the net result that we're all hoping to get. What we run into with all construction, but especially multi-residential construction, and there's a couple of different styles of, we'll call them noise disturbances, that can come in and disrupt the assembly as a whole, or disrupt your style of living as a whole. And the first one that we're going to discuss is airborne sounds. Whether that is your neighbor talking too loud on the phone next to you, you've got a rambunctious family that happens to live next to you or above you, myself included. My 3.5-year-old has no concept that he may be making noise when he's jumping off the couch at 8:30 at night and disturbing our neighbors below, but so be it. Do you have a neighbor who thinks that he's some rock god and likes to play everything on 11 at 4 o'clock in the morning? These are all different airborne noises. Traffic's another great example where these noises can come in through the assembly. It's what we tend to call more of a leaked airborne noise, and how we can try and mitigate this with the use of different types of membranes or just assemblies as a whole. So from a tile standpoint, airborne noises, is this something that we can really fix? Not necessarily, but it's something, one of the noise disruptions, or however you want to call it, that we can really look at as a full assembly, and understanding why we may be getting certain ratings that we are. Another major one that we get is structural vibration. Once again, I live in a condo, so I run into this on a fairly regular basis, where our garbage compactor, I can hear that thing turn on even though I'm 7 or 8 floors up above where it is. But there's different ways that we can, from a design standpoint and a construction standpoint, how we can try and mitigate it, whether it's the water pumps or trash compactors or HVAC assemblies. In a lot of cases, we can look at these and try and isolate the machinery as a whole, whether that's putting it on sleepers, i.e., whether it's a rubber or a foam pad, how they could be suspended from a ceiling, depending on the installation and how it's being done, different blockouts and whatnot. In some cases as well, I see this a lot with multi-residential construction, where they try and over-engineer and soundproof a room to ensure that the vibrations and some of the ambient noises that can come out of some of these machinery aren't going to disturb the rest of the area, whether that be office, residential, et cetera, et cetera. The last major type of sound that we run into is impact sounds. Once again, as I said, I live in a condo. I run into this on a fairly regular basis. And another great example is, over the weekend, I was installing a new microwave because my old one decided to give up the ghost. I know that there was a lot of impact noise of me having to drill new holes through my drywall substrate, and thank goodness I have a neighbor that's pretty accommodating, but you get these impact noises of people hammering or slamming doors, kids not understanding that they could be making a ton of noise. These are noises that where more so we can focus on with sound attenuation membranes, and how we can mitigate that through the tile assemblies, through the stone assemblies, into the wall, ceiling, floor below and around. So measuring these noises, there's a multitude of different ways on how we do it, but what we're trying to achieve within the industry is we're trying to reduce the noise transference over the hearing range of a normal human being, which is somewhere between about 125 and 4,000 cycles per second of that wavelength. And reducing that sound is your STC class is what we're trying to achieve, or your sound transmissions class. So the more that we can engineer a system, floor, walls, ceiling, whatever it may be, and reduce that vibration coming through the assemblies, in turn will help mitigate that sound transference from one area to a next. There's a couple of different test methods on how we can achieve this, or how we can test to see what the assemblies are going to look like. Generally speaking, with STC testing, we're looking at an ASTM E90 or an ASTM 413. When we're doing field testing, i.e. the assembly has been put into a building itself, and some additional testing may have to be done. We're looking at an ASTM E336. So some examples of what that looks like. Here's an example here of an ASTM E90 where we've got a sound source, we've got an assembly makeup itself, and then you would have a receiving chamber or a microphone chamber on the other side. This is the technique or this is the test that we use a lot to determine, or a lot of manufacturers will use to determine how good the assembly is going to be in that overall construction, and how as a manufacturer we're able to say as an assembly we can achieve certain STC or IIC requirements, and market our membranes and assemblies based off that. One thing though that I always like to throw out is it's great to have your STC or IIC requirements and what that looks like, but real world examples of how a floor assembly or a ceiling assembly is going to look versus how it looks in the lab can be a little bit different. So I always like to throw in a little bit of caution of, yes, we'll have manufacturers that will state we have an STC of, or an IIC of, let's say high 60s, low 70s. But in a lot of cases, when we get into the real world examples of how it's being done, and this is why we like to do field testing as well, your rates may be more so, let's say high 50s, low 60s. And a lot of that comes down to construction is not done the same way in the field as we do in a laboratory itself. So always something to keep in the back of your mind. Here once again is that example of an ASTM E336 where this is a field testing that's being done to see how good the assembly is. In this style testing, you may be able to see it, or you should be able to see it in the photo itself, but you've got that kind of black orb. This is the device that's emitting the different sounds throughout the range. And then you would have a listening device that you can move throughout the structure to see how all of those assemblies work together and how well it's mitigating those sound throughout the entire structure. Now, this is something that from a specification standpoint or from the engineering standpoint, we see it being used occasionally. I'm trying to think, with my tenure in the industry, I think I've been involved in maybe only 2 or 3 projects where we've gone as far as having to do field testing for airborne sound and how that's being isolated. But it does still exist, but also understand there's that cost component to it as well, and how that's going to be incorporated into the assembly. So additionally, on top of your STC numbers, we've also got our IIC, or impact insulation class ratings. We used to also have INC, or impact noise ratings. This is a little bit of an older number, so or a classification. So if we are seeing it in specifications, or you do still have it included in your specification, the industry itself has moved away from INC into IIC requirements. So it may be time to make that shift. Once again, because it's the construction industry and we all love doing our testing, we have ASTM standards for testing for these requirements as well. Now, this is an example here of laboratory testing, ASTM E492 for the impact sound transmission. This is where we have that floor assembly, similarly to the slide that I had, I think 2 or 3 slides ago, where we can test the entire assembly from the tile, membrane, and mortar all the way down to the ceiling structure below. We've got a box that's about the same size as a desktop tower that's got different tapping pads on it, and it will be used to tap the assembly itself. And then you'll have your receiving chamber and your microphone below to correlate and calculate how those numbers are going to come out into the assembly. Once again, as I always like to say, real world versus laboratory can be a little bit different. So ensuring that there's that real expectation of, yes, you've written a specification, and yes, the manufacturers will tout a certain thing, but Real world can be a little bit different. Then, as I said previously in the last two slides, INC is a little bit of an older number. As Will said, I'm from Canada, so this kind of makes sense to me and doesn't at the same time. INC ratings, we start with a baseline, and then we're adding and subtracting numbers to it, much like how all you fine folks in the US with your Fahrenheit measurement, where you start with a base 0, or what we have for 0 degrees, and then you start adding and subtracting numbers to it. That's how INC is done, where IIC and STC, it's a base 0 that you build off that. So when we're looking from a noise measurement standpoint, an STC rating of 25, if you were in another room and there was an STC rating of 25, the way I'm speaking now, you would clearly be able to hear that in the next room with a 4 below or whatever it may be. If we had an assembly of an STC of 30 and I was speaking slightly louder, but you're in that floor below or next door, you could still understand me fairly well of what I'm saying. Once again, STC of 35, I'm still there. You can still hear some level of noise, but it may not be as clear as it would be as if you were standing next to me. The analogy I like to use for this one, and to some degree I think I'm dating myself a little bit here, but anyone remember the old Peanuts and Snoopy commercial or cartoons where you had the teacher, and anytime anyone ever talked to the teacher was wah, 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 wah. That's what we're seeing with an STC of 35. STC of 45, people are really going to have to try and listen hard to be able to hear that I am speaking. And then an STC of 50 is you can't hear me speak because of how that assembly's been built out. So what does an assembly look like for floor rating? So once again, I'm Canadian, so I'm using the TTMAC standards. There are equivalent TCNA standards, but as a proper Canadian, I'll apologize for being Canadian and using Canadian standards or examples. But for a concrete assembly, we have TTMAC 331F detail E. This is an example of where you have your concrete slab. You'll have a primer and or a bonding mortar. You'll have your sound attenuation membrane. You'll have your bonding mortar for your tile and stone again, and then your grout. For the plywood substrate, you'll have your joists, you'll have your plywood substrate. Once again, you'll have that primer and or bonding mortar to bond the sound membrane to the substrate. You'll have your sound membrane itself, bonding mortar, tile stone, grout, etc. The key things with this, and this is where laboratory testing and real world testing really come into play, is what I'm trying to show here with the arrows. And I'm not sure if you can see my cursor as well, but these blockout strips are extremely crucial when specifying and when drawing these assemblies into the construction documents for multi-residential or residential or commercial construction, because what these are doing is they stop any sort of sound wave coming through the floor and transferring into the wall assembly, much like it stops or hopefully reduces a lot of the sound wave transference coming through the walls into the floors and into the substrates below. Now, ideally, in a perfect world, if we were trying to make a building where there is zero sound transmission altogether, you would have generally rubber sleepers underneath the wall assembly, so the wall can't touch the floor. Much like what we're showing here, you've got a tile assembly, but the tile assembly is not touching the cement board or gypsum or concrete masonry block assembly. So it would stop all those different sound transferences coming through. Now, here's another example here of a 3D breakaway showing that assembly with the ceiling below and how we're mitigating that. Are we using a rubber silicone joint? Are we using a prefabrication joint to try and mitigate that sound transference through? And that's really the critical part, where when we're looking at these tile assemblies, trying to mitigate or trying to inhibit that sound wave from transferring through the assembly into the wall and then reverberating out throughout the rest of the building. So let's kind of bring it back to a 30,000 foot level here, and we're going to look at some kind of baseline measurements for both plywood and concrete construction, and where we start to have to build our assemblies based off that. So generally speaking, concrete, regardless of the mixture and how it's being used, it's fairly, your results are pretty uniform across the board. If you have a 6-inch thick slab, you're generally going to have about a 30 decibel reduction. If you've got an 8-inch thick concrete slab, you're generally going to provide about a 32 decibel reduction of that sound transference coming through. As I said, this is generally fairly universal, regardless of the mixture of the concrete or the chem mixes that are being put into it. This is generally what we can experience throughout. For your wood construction, your 4-6-story low rise, whatever it may be, generally with a 2x10, 16-inch on center, where we've got a 3/4-inch plywood assembly built on top of it, as well as a 5/8 gypsum board below for the ceiling, we are getting approximately a 32 decibel sound reduction before any flooring assembly has been put on top. So when we look at this from a building code standpoint, and I'll talk about this more right at the very end as well, but from a building code standpoint, we're generally looking for an STC and IIC of 50, as per International Building Code. So we're already 3/4 of the way there. It's just, how are we now going to mitigate that system, or how are we going to design that assembly to work all the way through? So, as I said, we're trying to achieve an IIC and an STC of 50. Depending on whether we're working with concrete or plywood, we're going to have to make up somewhere between 18 to 20 decibels to achieve that IIC and STC of 50. Ideally, we're looking for higher because, as I said, it makes quality of life a little bit better for the residents that are in those dwellings if it's a multi-residential project. But your baseline, generally, we're making up those 18 to 20 decibels. Now, there are ways that we can cheat this as well. We can do drop assemblies that have an insulation built into it that can help cheat the system. We can do double layer gypsum board that can also help mitigate the system. So depending on what sort of flooring type that we're going to be putting in, we can help build up those systems one way or another. So we can rely less on maybe what types of membranes are being used, etc. But something to be aware of. With the IIC, we do have different testing requirements as well. ASTM E2179 is your laboratory testing for concrete substrates. And then your field testing is ASTM E1007. So they similarly go back to the previous slides where we're building up that assembly in a lab, and then how it's being tested essentially in an echo chamber, and then having your microphones above and below and around it to see what the results are going to be for it. So getting through all that base knowledge there and the base understanding of what we're looking at with IIC and STCs, are all membranes the same? Let's look at the tile assembly itself now. The long and the short of it is no. Not all membranes are considered are the same. The one that's most prevalent for the tile industry and the one that I tend to have to push back a lot on when I'm dealing with the engineers and my architects and specification writers is, does the membrane that's being proposed comply with ANSI A118.13, which is the ANSI standard for bonded sound reduction membranes for tile or for thin set ceramic tile installation. Generally, if the membrane does not comply with that, we can throw it out because it's not going to be able to work within the assembly itself. And it hasn't gone through the insured testing as a whole to know that we're going to be able to bond to it. Another question that I always like to bring up and that we need to look at as design professionals is, how's that membrane being installed? Is it a peel and stick product? Is it a mortar adhered product? Is it a loose lay product? We tend not to see loose lay products as much, but they do exist within the industry and they have their places. The reason why I like to bring this question up more than anything else, outside of the ANSI standard, is depending on the installation and depending on the timeline that we're looking at and overall value of the project, this can sway a little way, left or right. If it's a project where we're doing, say, a tenant improvement, a mortar applied or a mortar adhered membrane may not necessarily be the best choice, because there's a longer cure time before you can come over top and set your new tile assembly over top of that. Maybe a peel and stick product is going to be a little bit better. But if we're working with a peel and stick product, we're going to have to look at the substrate a little bit more closely, because do we need a primer to go over top? 99% of the time, yes, we will need a primer. Okay, great. What type of primer do we need to go over that substrate? Is it a porous concrete? Is it a non-porous concrete? Is it a plywood? Are there contaminants on that substrate? And how is that going to have to be mitigated prior to installation? One of the other questions that comes up a lot, or that's good to discuss, is a lot of membranes that are manufactured can be dual role. They're not just a sound control membrane. They may also be a crack isolation membrane. They could be an uncoupling membrane. There could be thermal values to it. It could have some waterproof components to it. So, excuse me, what are we trying to achieve? Unfortunately, it's one of those where I see it a lot, mainly in penthouses for 30, 40 story concrete, where we're trying to cram all the different types of membrane into one. And in a lot of cases, there isn't one membrane that does crack isolation and sound control and thermal and waterproofing and you end up with this huge multi-layered assembly before you're even getting your tile put on top. So understanding or focusing on what's required for that installation, and then picking the rest membrane or the best membrane for that application. Now, also, how thick is that membrane that's being used? And how is that going to change the overall rating that we're looking to achieve? As well as how is that going to now interact with other floors that are being installed in the area? You could still be going to tile, but let's say you've got a sound control membrane in the main living room and dining room and kitchen, but in the washrooms, you're only using a waterproofing membrane. Okay, well, if your waterproofing membrane is 1 to 2 millimeters thick, but your sound controlled membrane may be 3 or 5 or 7 or 9 or 12 millimeters thick, how are we now building up that assembly in the areas where we're not using a crack ice or a sound attenuation membrane to ensure that when all the tile assembly is done, we don't have any micro ramping here and there, and there's no lippage, and the floor is flat and smooth across, which all the areas, which is obviously what everyone wants. Contrary to what Google says, and as we all know, Google's always right, but you can't just put more thin set on the floor to build up your tile assembly. That's not how it works. In cases like that, when we're working with different thickness membranes, we may need to look at it from an aspect of, okay, in certain areas, we are going to have to patch or mortar bed or level up to ensure that everything's going to be flat and smooth across. Or one that I run into a fair bit, and I was just dealing with 2 installations last week of this case, where they're going to ensure that the slab in certain areas is poured slightly less than the other areas. So when all the flooring is put down, it's all going to be universal across the board, and we're not having to deal with excess leveling or patching or mortar bed applications to build it up. One of the biggest concerns that I always run into with sound attenuation membranes is a lot of sound attenuation membranes are not rated for commercial use, or not rated especially for heavy commercial use. So once again, this is an excerpt out of the TTMAC manual. I know there is similar nomenclature in the TCNA manuals, but if you're working in a light or heavy commercial area, as I said, a lot of these membranes, they have a compressive characteristic to it, and that constant rolling point load, that constant weight transference across the floor, can over time lead to a degradation of the bond performance of your tile through the bonding mortar to the membrane to the substrate, and you can run into bond failures over time. A great example of where I saw this happen, and it was less to do with a sound control membrane, it was an uncoupling membrane, but a great example of it was we were doing a mall renovation, and they were doing it through phases. You know, they were doing, I think it was 4,000 or 5,000 feet at a time at night when the mall's closed, and then come back. At the same time that we were doing a site walkthrough, there was a young kid riding on one of those cleaning Zambonis, and he must have thought that he was Michael Schumacher or the latest Formula One champion, and came ripping around a corner, and the tile sheared off that membrane. And it was determined over use and over years of the existing membrane being there, and that constant rolling point load, it started to break down the assembly itself and allowed that tile to shear off the membrane. So, good rule of thumb: if there's any concern on whether the membrane is going to work within the assembly, obviously check with the manufacturer first. Look through their technical data sheet, see if they have any white papers on how that assembly is going to work, and if the membrane is going to be appropriate for that installation, as well as if you want the added insurance. And if there's the time allowance within the project itself, have a Robinson test done. I don't have a photo of a Robinson test here, but to kind of go down a little bit of a rabbit hole, where Robinson tests are, it's an assembly that's put onto a concrete pad, and there's a wheel that runs around. And that, as that wheel runs and as the rotations are being done, it starts off as a rubber wheel and then a metal caster wheel, and more weight is added on top and on top and on top. And depending on the amount of rotations on that tile assembly itself, will give you a residential rating, like commercial, heavy commercial, industrial rating, and that can show what an assembly looks like. So if there's some concerns, and if there's the time allowance and the budget allowance for it, always a great thing to do to ensure that it's going to work for those installations. So looking at real world, assemblies, this is once again showing a little bit of in the top or the left-hand side of the slide from the TTMAC manual. This is showing a different assembly being done, where you've got your plywood substrate, that membrane's being put on top, and then your furniture in your rooms being put on top of that. Now, the photo in the center here, this was a dorm kitchen in a university where it was being done. And, as I'm sure all of us on the call here have spent some time at a university and or college dorm, much like my 3.5-year-old, they're not the quietest of people. So trying to mitigate some of that sound transference is always key. Now, here's an example here of a real world installation where a membrane has been put down with your concrete substrate, and then tile assembly being built over top of that. Some other examples that we're looking at, once again, going back to those dorm rooms. Yes, there's carpet in this photo here, but I've seen it where, once again, those washrooms, those the kitchen areas, the prep areas, the common areas where they may have tile installation, how that membrane is being incorporated into the assembly itself to help mitigate the noise, whether it be plywood or concrete. Penthouses, a lot. We see this, multi-residential, we see this a lot, where sound control membranes are being used to help mitigate some of that sound transference coming from one area to another. Just for better life, of all the residents, as I've been saying. Offices, main lobby areas, and this is one of the things where I very briefly touched on it in one of the previous slides, but a lot of these sound control membranes as well do have a thermal rating to it. So if you've got a main lobby area where there's less concern about the sound transference into the parking garage below, but that parking garage below does, by nature, it's a big open void of concrete. It tends to be significantly colder than what the main area wants to be. And some of these sound control membranes will have a thermal rating to it, will have an R rating to it, and can help bridge some of that thermal transfer through the assembly, making the main living area a little bit more palatable to live in. That goes back as well. We'll go back to the penthouse assembly. If you're incorporating in a electric heating assembly, or if there's a thermal heating assembly being put in through hot water piping, understand that if the heating assembly is, say, built into the concrete substrate, your thermal transfer is going to take longer if you're using a sound attenuation membrane within that assembly itself, because it's adding an additional layer into the assembly, and that heat transference is going to take longer. So while insert whatever thermal company it is, will advertise that, yeah, you can heat your floor within 10, 15 minutes, whatever it may be. Understand that, as I said, incorporating that sound attenuation membrane into it, or any membrane at that point, will take longer for that assembly to allow the heat transference all the way through. Another example, or kind of the last example that I want to look at here, is server rooms. These servers, they tend to make, and this goes back once again to the mechanical vibrations, they tend to make a fair bit of noise. They tend to make there's that slight vibration with them. So incorporating a sound attenuation membrane into it to help mitigate that sound transference through is a great way to do it. In a lot of cases as well, with these server rooms, they tend to be built on raised panel access. So the use of a raised panel access floor in conjunction with a concrete substrate, in conjunction with a sound attenuation membrane, makes these rooms almost completely isolated from the structure around it, and in turn, the sound transference is almost non-existent that you're seeing into the other assemblies or the other areas in the room. So generally with building code, this is the last little bit that I wanted to touch on, but generally with building code, whether it be international code councils, international building code, national building code, provincial, state building codes, we're looking for a minimum of an IIC and an STC of 50 when we're working with multi-residential projects. Going back to those earlier slides of your base concrete is generally a 30 or 32 decibel. How are we going to build that assembly over top? And in turn, what's the end use that we're looking for at? So while it can be as complicated as it may seem on the surface at a 30,000 foot level, when we're getting into it, the use of these sound attenuation membranes really can help bring that sound transference rating up to that minimum of 50%. One thing that I like to always bring up as well, once again, I live in a condo, so this is something that comes up. Anyone that has lives in a complex with an HOA, you'll completely understand as well. But a lot of residential strata corporations or office building corporations will have minimum sound transference requirements outside of what building code is going to be. This is an excerpt out of my strata bylaws for my building itself, but how are we going to achieve that? And it goes back to right at the very beginning of the presentation where I was stating how it's great that a lot of manufacturers will say, yeah, we can achieve X. We can achieve a 73 or 74 or 70, whatever it may be, or 60, 68, 69, 70 of IIC, STC, and that's great. The problem that we run into with a lot of these strata corporations is they will just grab onto a number because more is better and throw it in their specs and not quite understand how the whole assembly is going to work and how they're going to be able to achieve those numbers. And then once the installation is done, they're still getting the complaints where, well, I can still hear my neighbor, even though the right membrane was used. Even though, yes, this is one little excerpt out of the my strata bylaws, which says, we need to get a 72 decibel or higher of an STC and IIC requirements. I've seen other strata corporations, and I've been involved in other strata corporations where they say, on top of your IIC STC requirements, you also have to have your floor, if it is a tile assembly, 70% of it has to be covered by rugs or some additional topical applied product to help mitigate that sound, which if you're spending thousands, if not tens of thousands of dollars to have a tile assembly put down in your floor, you don't necessarily want to have to cover it up. But unfortunately, this is something that we deal with a lot with strata corporations because they don't have that understanding. One last thing that I get a lot as well, and primarily this comes from the strata corporations, is they'll get a hold of a membrane where on its own may have a sound transference of, for sake of argument, 17 decibels. So, you've got your 30 concrete slab, the sound membrane itself has 15, 20 decibels. Great. You've gotten close. If not, you've matched your 50 STC or IIC. Well, why don't we just double it? Why don't we just put 2 layers of membrane on top, and then we're going to have another 15 or 20 decibels on top, or decibel reduction on top of that. These membranes are not designed to be doubled up, nor when you double it up, are you going to achieve twice what that baseline is. At most 4 or 5, maybe, if you're lucky. But you're also now doubling up the assembly. And as I said, with are all these membranes the same? A lot of these membranes are compressive membranes. You've now added 2 layers of very spongy material there. So if it's a commercial installation, we can run into these issues of extra compression within the assembly itself, which could lead to possible failures down the road. So that's a little bit faster than I was hoping, but this is at the end. So Will, I'll let you open it up for any questions that may have come through in the comments. But if there's any questions that come up, my contact info is here. You're more than welcome to reach out, and I'm happy to discuss further, or if there's additional rabbit holes that you want to go down. I know Will's been populating the chat itself with a couple of comments and different articles in regards to these different standards, but the floor is open for discussion.
Excellent presentation, John. Thank you very much. A lot of information to digest. I definitely put links into the different standards, some floor testing, some videos. So there's a lot of assets in there. I'd like to open up the mic. Thank you, Mac. Said very well done. Open up the mic to anyone that may have a question. We didn't have any questions in the chat, John. I think you were so thorough. I'm
going to say everyone fell asleep, but I appreciate that.
Yeah, exactly. It was a low STC impact is what it was.
There we go. Yes.
You can see why Custom is installed on more commercial and residential projects than any other brand. Count on Custom, your partner in flooring preparation and tile and stone installation systems. To learn more, visit custombuildingproducts.com.